So I just thought about this question that I wanted to ask you guys. Check this out. Let me ask you, if you had a triangle with sides 1, 22, and 27, what would be its area? And notice right here, I'm emphasizing if you had. And the reason for that is because this thing does not exist. Why? Because if you have these two sides, let's say we just add them up, well, that's only 23. Unfortunately, this is not bigger than the third side, which is 27. So this triangle wouldn't exist. Because remember, the triangle inequality says when you add up any two sides of a triangle, the result of that has to be greater than the third side. But this is not true right here. So I would just say no such triangle. But I can say in the real world, because what if we just still do the math and let's see what happens, right? Because whenever you have a triangle with three sides, you can use the Heron's formula to find the triangle, and then let's talk about that. It does not have to be any particular triangle. It doesn't have to be right, because as you can see, this is obtuse, so this is totally not right. But if I say A, B, and C like this, we can use Heron's formula to find the area, which is going to be the square root, and we do S times S minus A times S minus B times S minus C. What is S? S is what we call the semi-parameter. You just do A plus B plus C, which is just a regular parameter, but semi means half of it. So that will give you the area. But as I said, what if the triangle didn't even exist? Let's have a look. Okay, so in our case here, let's compute the S first. So our S will be 1 plus 22 plus 27 and divided by 2, not divided by 3. It's not the average, it's a semi-parameter. The top adds up to 50, divided by 2 is 25. And the area that we are trying to see, it's going to be the square root, and then we do 25 times 25 minus 1 times 25 minus 22 times 25 minus 27. Okay, if you work this out, you will see that inside becomes 25 times 24 times 3. But for the last one, 25 minus 27 gives us negative 2 from here. And the result of this becomes a negative number, negative 3600. And if you work out the square root, and by the way, if you don't want to continue, that's fine. You can just say no such triangle exists. That's what we did earlier. But if you want to continue, let's go ahead and say that's 60. Right, square root of 3600 is 60, but we have the negative right here. Let's go ahead and put down the I. So that would have been the imaginary area for this imaginary triangle. I thought was pretty cool. Now, I have a question for you guys. It's not that hard, but it's very fun to think about. Is it possible for us to use the Heron's formula and then we end up with a legitimate answer, right? A real number right here. However, the triangle didn't even exist in the first place. So can you think about three sides, right? A, B, C. Do this and then plug that in. The result inside of the square root is positive, but it fails the triangle inequality. And I think that's pretty fun. Go ahead and try that and leave a comment. Let me know what the answer is.